Okay, for this complex numbers question, okay, given the argument a plus ib equals theta, a greater than 0, b greater than 0, find in terms of theta and pi the value of part 1, part 2, and part 3. Okay, so this is a question that tells you on your Argand diagram. Okay, so you need to know that a plus ib, okay, when a and b are both greater than 0, it's actually going to be in the first quadrant. Okay, so let me just quickly draw the axes. Okay, these are the axes. This is the axis for the Argand diagram. Okay, so where will a plus b be? Okay, a plus ib will probably be somewhere. Let's let it be here. Okay, some unknown location. Okay, where this is a and this is b. Okay, our this is the real axis and this is the imaginary axis. Okay, so this is your a plus ib. Now, what happens to part 1 where you are finding negative a plus ib? So negative a will be somewhere here. Okay, and let's change another color. Okay, let's change to green. So let this be now negative a, and when we draw the line, it will be somewhere here. So this is negative a plus ib. Now we know that this is going to be theta. So using basic angles, right, here is going to be theta as well. But where does argument comes from? Argument always comes from this real axis. This is where your argument is 0. And then we need to find this one. Okay, so for your part 1, you need to draw this Argand diagram as part of your working, okay, to show your understanding of it. So for argument of minus a plus ib, based on the working, you can see it's going to be just pi minus theta. So that is for part 1. Now part 2, minus a minus ib. Where will minus a minus ib be? Okay, minus b will be somewhere here. So when we draw our complex numbers, okay, this is where your minus a minus ib comes in. Again, the basic angle for this is the theta. So we need to find this one. Okay, and the magnitude of this is going to be pi minus theta as well. But it goes in the clockwise direction, the other direction. So this direction is negative. Okay, the other direction here is positive. So for part 2, the argument of minus a minus ib is the negative of the magnitude of pi minus theta, which is theta minus pi. Okay, so that is for part 2. Okay, this is for part 1. Now part 3, b plus ia. Okay, so b plus ia. Now let me redraw the Argand diagram quickly. So you can see that there is the x and y direction changes. Okay, let me just draw the Argand diagram quickly so that you'll be able to see. So this is the axis. This is the imaginary. This is the real, the A and the B. Okay, so let's change to A plus IB. Okay, so this is A plus IB. How about B plus IA? We don't know where it is. Okay, so let's let it be purple. So let this be B plus IA. Okay. Let's make A larger so that it's clearer. Okay, let's make this as the A. So let's get rid of this. And for this, we'll be getting it here. Okay, so our B now, we can let this be B. And then let it there be A. Okay, so for here, now we get this. This is our B plus IA. So now, For A plus IB, this one, this is our theta. Okay, it's tangent inverse of B over A. So the other way that I can see your theta is tangent inverse of B over A. So this is also theta. So to get your angle, this will be the argument. Okay, and you can see that it's going to be pi over 2 minus theta. Because this is pi over 2. So because of that, for part 3, it's pretty simple. Argument of B plus IA is equals to pi over 2 minus theta. Okay, you can also go use the properties of tangent and cotangent to help yourself. It's the same thing. Okay, but here it's just a pictorial form so that you can see. Okay, so it's just a right angle triangle. The theta is now to the vertical. But argument by definition is going to be from the real axis. So that's why this is the answer.